Hello, everyone. Good afternoon, and thank you for joining us for today's special presentation of ENERGY STAR single-family homes, new homes programs as part of the Mass Save Residential New Construction, Passive House, and All-Electric Homes Workforce Development Initiative. My name is Keegan Evans, and I'm with ICF, the lead vendor working on behalf of the sponsors of Mass Save to bring you this training series. Today's training will be recorded and will be posted online afterwards, as well as shared with anyone who registered. And again, this training is brought to you at no cost, thanks to the sponsors of Mass Save. A reminder, Dean, if you want to go to the next slide, a reminder that as part of this training and workforce development initiative, we do offer a 50% cost reimbursement for individuals pursuing either Passive House or ENERGY STAR professional accreditation. So that includes the cost of the training and the certification process. And once you are fully certified, you can submit your application to us for the 50% cost reimbursement. So some exciting news in the world of Mass Save residential new construction. Dean, if you want to go to the next one. So as of July 1st, we have officially launched our new incentive program a bit ahead of the new 3-year plan that's beginning in January. So for single family incentives, homes with 1 to 4 units, they must be fully all electric. No fossil fuel equipment will be allowed in the house to qualify for incentives. And there are 3 incentive tiers, a base tier, an ENERGY STAR tier featuring NextGen, which we'll hear about today, and then a Passive House tier. And you can see the incentives there for each tier. And in addition, there will be market transformation adder incentives, things specifically for types of equipment or additional certifications that the homes can receive to increase the incentive per unit. On the multifamily side, last slide, Dean, thank you. Again, 3 tiers, base, ENERGY STAR, Passive House. For that ENERGY STAR tier, the certification level will be the multifamily new construction version 1.2 certification, which we'll hear about in this series at noon on Thursday. So if you're interested in learning more about that, please do register for part 2 of this session. And then for multifamily, again, it must be all electric with the exception of domestic hot water, which will be allowed to utilize fossil fuels for the time being. And again, some additional market transformation adders available for specific equipment types and additional certifications. So if you're interested in learning more about these incentives or how to enroll a project, reach out to us at the program. And so with that, I will introduce our speaker today, Dean Gamble from EPA, to talk about ENERGY STAR single-family new homes. Dean, welcome. Thank you for joining us.
Yeah, thanks for having me today. I'm excited to be presenting to you, especially with the great program and incentives that Keegan was just talking about. Before I go any further, I'm just going to pause for a second here and close my Outlook so I don't get unhelpful reminders about other things I'm supposed to be working on. Yeah, I'll save a draft of that. Okay, let's go back here. All right. So as Keegan mentioned, this is Dean Gamble speaking. I'm the technical manager for the Single Family New Homes Program, and I'm very happy to be talking with you today. So let me briefly run through the agenda and then we'll jump right in because we actually have quite a bit to cover. I'm going to start with a brief summary of the new federal tax credits, which is actually driving a lot of interest in national version 3.2 of our program, which we'll be talking about today. It's an even better picture in Massachusetts, where you have the generous local incentives that complement this. Next, I want to provide a general overview of the Single Family New Homes Program, including the key features applicable to nearly every certified home. Third, we'll do a deeper dive into National 3.2, what differentiates that version from other versions and how to prepare for it. And then finally, I'll end with an introduction to ENERGY STAR NextGen, which Keegan just mentioned there are specific incentives tied to. And that builds on top of 3.2. So let's kick things off. Yeah,
Dean, I'll just add that for attendees today, for questions throughout the presentation, go ahead and put them into the questions pane on your GoToWebinar control panel, and I will relay them to Dean throughout the presentation. So just wanted to add that in.
Yeah, thanks, Dean. So let's kick things off with the new 45L federal tax credits for builders of energy efficient homes. You've probably heard something about them, hopefully you have. As part of the Inflation Reduction Act that was recently passed, the Section 45L new energy efficient home credit has been updated and extended through 2032. So for eligible homes and apartments that are acquired on or after January 1st of 2023, the tax credit is specifically tied to certification to an eligible version of the relevant ENERGY STAR or DOE Zero Energy Ready Homes program requirements. So unlike the last iteration of the tax credit, which in recent times was retroactively extended at the end of each year, this new tax credit actually lets you plan ahead, which is a really nice feature. Now, the tax credit applies to single-family homes, multifamily homes, and manufactured homes, but today we're just going to be focused on single-family homes, which covers detached, new single-family homes, duplexes, and townhouses. For those that are certified to the minimum eligible program version, which varies by program type, year, and location, a $2,500 credit is available for ENERGY STAR, and double that amount, $5,000, is available for Zero Energy Ready homes. So let's talk about what we mean by minimum eligible program version. For ENERGY STAR, the minimum eligible program version for the tax credit is determined relative to the dwelling's acquisition date, so not its permit date. And this can be a little confusing because it's different than for plain old ENERGY STAR certification, where version enforcement is based on permit date. It's also different from DOE's Zero Energy Ready Homes program. And this is a rule that Congress decided when drafting the legislation, not us. So unfortunately, it's not something that we can change on our end. It's just something to be aware of and plan around. The minimum eligible program versions for the tax credit is key information you need to know as a builder or rater. And you can find the tables with that information on the ENERGY STAR website, the link that's shown here. We'll send around the slides after the fact, so you can click on that. Currently, those tables are available for acquisitions made in 2023 through 2026, and we'll look at those in just a minute. And finally, this is something that has caused some confusion to partners. Note that the minimum eligible version required for the tax credit can be more stringent than what is required just for ENERGY STAR certification. Okay, so let's look at those tables. In 2024, for most states, including Massachusetts, the minimum version required for the tax credit for single-family new homes is National Version 3.1 of our program. There are some different requirements in places for other states, but I'll skip over those today since we're just focused on your state. Beginning in 2025, there are big changes in Massachusetts for single-family new homes and another number of other states, and that's the transition from National Version 3.1 to National Version 3.2. And again, there's some changes in other states that we just won't cover today. From a quick glance, though, you can see that most states will step up to National Version 3.2 for the tax credit beginning in 2025. And this is a key reason why so many of our partners are preparing for version 3.2 now. And then for 2026, National Version 3.2 will continue to be the minimum eligible version in most states, including Massachusetts. So let me do a quick quiz, just a couple of these throughout the presentation to see if you're tracking. So let's say that we have a home in Massachusetts that's permitted in January of 2025, and it's acquired in August of 2025. What's the minimum program version that has to be used for a home that's just pursuing certification? So they just want to put the ENERGY STAR label on the house, for example. And what's the minimum program version if they want the 45L federal tax credit? Now I realize you might not have this memorized, so I've included a little cheat sheet here. In the lower left is the table of applicable program requirements, versions, and revisions for certification. And on the right is the minimum versions eligible for the tax credit for acquisitions in 2025. So is the answer A, that National 3.1 can be used for both certification and a tax credit in this example? Is it B, that National Version 3.1 can be used for certification, but if you want the tax credit, you have to step up to 3.2? Or is it C, that you have to use version 3.2 for both certification and the tax credit? So Keegan, I don't think I can see the poll on this end, but I see that it's open. So if you can just let me know when the results come in. Oh no, I can't see it. Great. I see that you're reflecting.
We've got about 50% have voted so far, so we can just give it another couple seconds. And so far, about 45% have voted for C, 33% for B, and about 20% for A.
Okay. So we'll give it just another second or two. Sure, some people didn't know they were going to be quizzed, so they're putting it down to them.
More votes coming in for C. It's over 50% now. So I'll go ahead and close the poll.
Okay, sounds good. Okay, so the correct answer in this case is actually B. So if you're just pursuing certification, you just want to put the label on the house and call it an ENERGY STAR home, you can certify to National 3.1. EPA says that's A-OK. Congrats, you've met our requirements. The tax credit, which was defined by Congress, they said, well, if you want federal money from the federal government, then we're going to make you step up to an even more stringent version. That's where 3.2 comes in. So I called that quiz out because it has caused some confusion, and it sounds like it was causing a little confusion here as well, because most people are voting for C. There is sometimes a difference between the version required for certification and the one that you have to meet if you want the federal tax credit. So good to keep in mind. So that's basically what I have on the tax credit today. If you have questions about it, feel free to reach out to us. However, all we can really do is relay information that's already been provided in the legislation or by the IRS. So in a lot of cases, we'll have to direct you to consult with a tax professional. Okay, with that context, let's get into the details of the ENERGY STAR Single Family New Homes program. And what I want to cover in this section are the requirements that apply to all the versions except in the Pacific and in the Caribbean, which Massachusetts is definitely not in either of those locations. So let's start with the eligibility requirements. New single-family, multifamily, and manufactured homes are all eligible to earn the ENERGY STAR using customized program requirements for each sector. Across all those sectors, to earn the label, a home or an apartment has to be independently certified to meet EPA's rigorous energy efficiency requirements. Now, nearly 3,000 builders, developers, and manufactured housing plants are currently ENERGY STAR partners, including all the nation's 20 largest home builders. Over 190,000 new homes were ENERGY STAR certified in 2023 alone, and 12% of all US homes built in 2023 were ENERGY STAR certified. So we're really proud of those numbers. Now, let's talk about the building types that are eligible to participate specifically in the single family new homes program. They include detached single family homes, detached two-family homes such as duplexes, and townhouses. So if you're building or rating one of these home types, then this webinar is for you. And if you're involved with multifamily buildings or manufactured homes, then you may want to look into one of those other two programs. As Keegan mentioned, there's a webinar on Thursday about the multifamily new construction program. So that was pretty easy. Now let's discuss the key elements of the single family new homes program requirements. Here they are. We can fit them on one page, and they're broken into 4 categories: efficiency and testing, comfort, air quality, and durability. So let's review these one by one. I'm going to start with an energy rating, which includes third-party inspections. Simply put, you don't know what you don't inspect. By some estimates, more than 80 individuals representing over 24 different trades are going to touch a home during its construction. Site supers have a lot to keep track of. They're not always going to have the bandwidth or the training to look at every single detail. And it certainly won't be the code inspector who's paying attention to all of this stuff. So that's where a third-party inspector called an energy rater comes in. It's a critical extra set of eyes that should reduce the liability of a builder by keeping tabs on these things. In addition to visual inspections, it's the rater who has the equipment and the expertise to measure key features like infiltration, duct leakage, ventilation airflows, and installed HVAC performance. Now, hopefully you're already familiar with ratings, and I know in Massachusetts a lot of you are, but if not, here are the very basic steps as they apply to ENERGY STAR. First, the third-party inspector called the rater completes a preliminary energy model and ENERGY STAR design review before construction even begins. During construction, the rater completes 2 on-site inspections to complete what's called an Energy Rating Index, or ERI rating, which you may know as a HERS rating, and to verify additional ENERGY STAR specific requirements. And finally, the rater completes the energy model, registers the home with their home certification organization, and they provide documentation of certification to the builder. So doing an energy rating is an easy but critical first step. Every builder can, and I think should be, doing an energy rating on their homes. Otherwise, you're just flying blind. Now, fortunately, we know that a lot of builders have taken this first step, more than 360,000 homes were rated in 2023 alone. And in Massachusetts, this is so impressive, over 9,500 ratings were completed, representing 98% of all new homes. So that is amazing. The state is already doing a fantastic job on conducting ratings. As I mentioned, these ratings result in an energy rating index, or ERI score, that represents the relative efficiency of a home. You may know them again by their proprietary brand, HERS Ratings. And this is a scale that's roughly 0 to 100. A high score represents a home that uses a lot of energy, meaning it's not efficient. And like golf, the lower the score, the better. A low ERI rating means the home uses less energy and is relatively more efficient. So for context, an ERI of 100 is equivalent to a home that meets the 2006 IECC, and a score of 0 represents a home that uses no more energy than it produces. That means you can only achieve a score of 0 if the home has on-site power production like PV panels. In other words, an energy rating is simply an assessment. While it's a critical first step, it doesn't necessarily mean that the home is efficient. I mean, a terrible home like this can also get an energy rating. It might get a score of like 130, and that's better than not knowing it's 130, but it doesn't make for a good home. Because of that, we go beyond just doing an energy rating. We lock in above code performance. And in most states, including Massachusetts, we do this using what we call an ENERGY STAR ERI target for each home. Energy rating software automatically determines this target for each home. And let me quickly show you how that's done. Once the house that's pursuing certification is entered into rating software, the software automatically creates a target home with the same key architectural features like foundation type, house size, number of stories, and orientation, as well as the same location and fuel type. Next, the rating software applies what we call the ENERGY STAR reference design to that target home. And the ENERGY STAR reference design is a prescriptive set of efficiency measures covering the house from top to bottom. So insulation levels, infiltration, duct location, equipment, appliance efficiency, the whole shebang. Step 3, the rating software calculates the ENERGY STAR ERI target, which is the ERI that results from the target home configured with that ENERGY STAR reference design. And then once the ERI target has been calculated, builders then select efficiency measures that meet or beat the ERI target. And note this is the same process that the Zero Energy Ready Homes program uses to define its performance target as well. They just have a different reference design. So for example, let's say that you model a home you want to certify and the software calculates that the ENERGY STAR ERI target for that home is a 52. That means you have to select efficiency measures that meet or beat 52 for this particular home. So none of the ENERGY STAR reference design measures are mandatory for hitting that target, but if they're not used, then other measures have to be selected instead. Okay, so what are the ENERGY STAR ERI targets? Well, that depends on the program version. Now our goal is to define targets that produce savings of at least 10% relative to code-built homes. And for most states, single-family new homes, national version 3.1 is in effect, including in Massachusetts. Those are the states that are shown in blue. And that version requires an ERI target of about 55 to 65 for most homes. National 3.2 is implemented in states that have adopted the 2021 International Energy Conservation Code, or an equally rigorous code, and those are shown in yellow. Now, additional states are going to move to National 3.2 if they adopt the 2021 code, and Massachusetts is definitely a state that we're keeping our eye on. In addition, as we discussed, it's also required in most states starting in 2025 to receive the federal tax credit. And as you'll see later in the presentation, it's also required for ENERGY STAR NextGen. So National 3.2 has a lot of applications, and it has a more stringent ERI target, which is about 45 to 55 for most homes. So that is the foundation of the program, above code performance that's demonstrated through a third-party rating. If you're already doing that, as a lot of people are in Massachusetts, you're more than halfway towards certification. On top of the efficiency that's locked in, we're just adding a handful of extra features. We're adding 3 comfort features, and the first is what we call a complete thermal enclosure system. And that means a few things. First, having high enough insulation R values and high performing windows to be effective. That's what we call the thermal backstop, and we'll talk more about that later in the presentation. So remember that term. Second, it means achieving grade 1 insulation installation. That helps the builder get the R value that they paid for, and it reduces the chance of comfort complaints. Third, it means air barriers and air sealing to help the insulation work properly, reduce hot and cold air from intruding, and reduce pests. And fourth, it means using strategies to reduce thermal bridging in your walls. The second comfort feature is properly sized and installed HVAC systems. Unfortunately, this just can't be taken for granted. Studies have shown that there's improper airflow in nearly 50% of residential systems. I didn't say that incorrectly, it's literally half. An incorrect refrigerant charge in 60 to 80% of systems. So you can't just assume that everything is okay. You need to actually check. Now, there are a few ways to accomplish this in the ENERGY STAR program, but the best way is through HVAC grading. That's a series of 5 tasks that the rater completes, resulting in a grade for the HVAC system, either 1 meaning great, 2 meaning okay, or 3 meaning bad. And for ENERGY STAR, you have to achieve grade 1 or grade 2. The third comfort feature is bedrooms that are comfort balanced. You know, homeowners spend more time in their bedroom than almost any other room, and when bedroom doors are closed, as they often are at night, air can become trapped. It's not enough to supply conditioned air to each bedroom. The air also needs a path back to the HVAC system. Now, there are a variety of ways to create a return air pathway, such as a transfer grill, a jump duct, dedicated returns, which are more common in the Northeast, or, not as recommended, maybe something as simple as an undercut door. You know, we had a builder who worked with us for like 10 years. They resisted this particular feature tooth and nail. They just didn't see the value in it. And then at some point, their in-house HVAC design team finally realized, it just clicked for them, that their HVAC systems were not working as expected. And they were not working because they didn't have the return air pathway. So they ended up incorporating this feature into all their homes nationwide, even where they weren't doing ENERGY STAR, because it's really important to include this feature. Okay, so moving on from comfort, we're adding 4 air quality features, which are more valuable now than ever before. Because we're building a high performance home, we're going to build it tight and ventilate it right. And that means we'll add a whole house fresh air system to deliver a consistent amount of fresh air into the home. Now, there are a variety of options to do this, from a bath fan with a special control to an inline supply fan, all the way up to something like an energy or heat recovery ventilator. But the point is, the system is going to have control over the air that enters the home instead of leaving it up to the whims of Mother Nature. This is now required by code in nearly half of all states, but even where it isn't required, it's really something you should be doing regardless for the health and comfort of your home buyers. So that was bringing fresh air in. The other half of the air quality equation is taking the bad air out, and so we'll add vented exhaust fans in the kitchen and in full bathrooms. Maybe you already know that cooking creates contaminants like formaldehyde, fine particulate matter, and excessive water vapor. You're really kicking up a lot of bad stuff into the air. There's a reason that commercial kitchens have enormous range hoods with huge rooftop fans. In the home, range hoods that are installed in recirculation mode just blow these contaminants, unfortunately, back into your face. So it looks good, but it's not really doing a whole lot for air quality. So we want these range hoods to be installed with ducts that go to the outdoors to get those contaminants completely out of the home. In some cases, they also have to meet sound limits. Moving on, each ENERGY STAR home and apartment includes a MERV 6 or better filter and the heating and cooling system. That's going to remove contaminants from the air as it passes through, and it has to be properly installed so the air goes through the filter rather than around it. So that is a very straightforward requirement. And the fourth air quality feature is combustion safety, which comes in a few different flavors. Most of our partners use power vented or direct vent appliances, or just use electric appliances, like the program is incentivizing, that avoid combustion issues altogether. Other options would include keeping the combustion appliances outside the home's pressure boundary, or having the rater do combustion safety testing. So whatever strategy you use, this is really just a question of due diligence to keep your home buyers safe. And finally, we have one key durability feature, the water management system, which basically means proper flashing to keep bulk moisture draining away from the home. In other words, don't tuck your raincoat into your underwear. That is sage advice for your whole life. This is simply a list of details for the builder to implement, not a checklist to fill out. And almost all of this is baked into code. So it's not really asking for much more than builders should already be doing. But we know it's super important for high performance homes because leaks and other moisture issues can be so damaging, And in fact, many of our partners go above and beyond these requirements already. For example, they have third-party assessments throughout the year. So that's it. You can fit the ENERGY STAR features on one page, an energy rating that locks in above code performance. That gets you about halfway there, with 3 added comfort features, 4 indoor air quality features, and a set of durability details. And just ask yourself, which of these features would you tell your client to leave out? Which would you leave out of your own home? And just how hard and expensive would it be to add these features after the time of construction? Okay, so at this point, you already know 90% of what you need to do to comply with National Version 3.2 because the requirements we just reviewed are applicable to almost every version of the Single Family New Homes program. Now we'll get into what differentiates National 3.2 from earlier versions and how you can prepare for it. Time for another poll. This is just a sort of assessment here to see where we're starting from. So tell me, how familiar are you with National Version 3.2? A, it's a stranger to me. This is the first time I'm hearing of it. B, we're generally acquainted. I have a basic understanding. Or C, we're best buds. I'm already assessing whether homes comply. So let me give you a couple seconds to think through that. All right, this is a much easier poll question than the last one because more than 50% of you have already voted. That's good. Give it just a couple more seconds to see if we can get that up to like 2/3. Okay. Okay. All right, almost 70%. That's great. So we had 40% saying it's a complete stranger, 52% saying you're generally acquainted, you have a basic understanding, and just 8% say you're best buds. So that tracks pretty well. Actually, you're probably ahead of the curve a little bit by being generally acquainted because it's a relatively new version. So a lot of people are still getting used to using it. So let's talk about this. For those who aren't familiar with National Version 3.2, the good news is that there's only 2 differences between that and National Version 3.1. First, a more stringent ERI target, and second, a more stringent thermal backstop. Those are the only 2 differences between National Version 3.1 and National Version 3.2. So if you've been doing ENERGY STAR, or if you've done ENERGY STAR in the recent past, National 3.2 is going to look really familiar. We talked a little bit about the ENERGY STAR ERI target and the thermal backstop in the last section, but now let's go into more detail. And let's start with the more stringent ERI target. So this is a chart of residential energy efficiency standards over the last 20 years. The 2006 International Energy Conservation Code, or IECC, essentially kicked off the modern era of residential energy codes. And it was followed 3 years later by the 2009 IECC. So it's around that time that we developed version 3.0 of the ENERGY STAR Single Family New Homes program. And the specs were meant to be at least 10% better than the 2009 model code. 3 years later, the 2012 IECC came out, so we released National Version 3.1 to again stay at least 10% better. The performance in the 2015 and the 2018 model code sort of plateaued, so version 3.1 continued to do its job. And then along came the 2021 IECC, representing another significant step forward. As a result, National 3.1 of the program no longer achieved meaningful savings relative to homes built to this new model code. And that's why we've defined a new version of the national program requirements called National 3.2. So each time a meaningfully more stringent model code has been released, we've done the same thing with version 3.0, 3.1, and now 3.2. In the last section, we discussed how the ENERGY STAR reference design is used to determine the ENERGY STAR ERI target for each home that's pursuing certification. So let's take a closer look at that. Here are the key enclosure measures included in the reference design for 3.2 in Climate Zone 5, where Massachusetts is located. The cells shaded in green are those that have been improved or upgraded relative to the 2021 ICC baseline. So we start with insulation levels that are aligned with the 2021 IECC prescriptive path, achieving grade 1 insulation installation, plus windows and doors that aligned with the latest ENERGY STAR product spec at the time that we were developing version 3.2, and an infiltration of 3 ACH50. And And now let's talk about the non-enclosure measures of the version 3.2 reference design in Climate Zone 5. It's configured with furnaces that are generally aligned with the latest ENERGY STAR furnace spec. Heat pump efficiency and AC efficiency align with the latest ENERGY STAR product specs for those categories. With all HVAC systems installed well, 100% of ducts located in conditioned space, an ENERGY STAR level water heater, and 100% LED lighting, along with an ENERGY STAR level refrigerator and dishwasher. So when this reference design is applied, it results in a target of about 45 to 55 for most homes. And by definition, if you include all the measures that we just reviewed, you'll hit that target. But you're not required to use those features per se. Builders are free to mix and match measures as long as they hit the ENERGY STAR ERI target. With that said, it's going to be sort of difficult to do that without several key features. The 2021 IECC installation levels are equivalent, ducts in conditioned space, and an instant gas water heater or a heat pump water heater. So you should start with the assumption that you'll need to include these three measures, and then if you don't want to use one or more of them, know that you're going to have to work fairly hard to avoid them and still hit the target. So let's explore those trade-offs a bit further just to give you a little more intuition. I modeled a 2,400 square foot, two-story home with a conditioned basement and a heat pump in Boston. And I started by modeling a home with the same features as the version 3.2 ENERGY STAR reference design. So these are the same features that you just saw a minute ago. The ENERGY STAR ERI target for this home is a 51, so squarely in the middle of that range from 45 to 55. And not surprisingly, the home achieved a 51 because it has the same features as the reference design. Next, I tried tweaking the insulation level. So I backed off from R60 to R49 ceiling insulation and down to R21 in the walls with no continuous insulation. To compensate, I improved the windows to 0.25 U factor with a slightly higher solar heat gain coefficient. And I increased the foundation walls to R21. So this worked fine. I was still able to hit the target. Next, I stuck with the modified shell, but I upgraded the space heating heat pump to 10.0 HSPF. In exchange, I backed off the infiltration to 3.25, and I took the default grade 3 for HVAC rating, so I wasn't even going to assess the HVAC rating system. That worked too. My third package stuck with the modified shell, but it upgraded the water heater to ENERGY STAR levels. That allowed me to take grade 3 HVAC again, plus avoid the HVAC upgrade. So I went back down to 9.2 HSPF. And finally, I stuck with the modified shell, but I backed off the infiltration a bit and used grade 1 HVAC instead. So you can see with these examples that you do have some flexibility to adjust things at the margin, but I think you'll find that you can't leave out the key features like ducts and conditioned space unless you're really going to double down on everything else. Okay, so the more rigorous ERI target is the first difference between National 3.2 and the prior versions, and the second key difference between National 3.2 and 3.1 is a more stringent thermal backstop. So as we discussed in the last section, one of the components of a complete thermal enclosure system is the thermal backstop. This is the minimum amount of insulation and the minimum window performance that must be met for the home to be certified. So regardless of the ERI target that a home hits, it can never have an enclosure that's worse than these limits and still be certified. But a home can trade off between ceiling, wall, and foundation insulation, windows, and doors to meet this thermal backstop. More precisely, the thermal backstop can be defined by a single number, which is the area weighted U factor for the enclosure. You simply multiply the U factor for each assembly by its area and sum those numbers up. You'll sometimes see this number referred to as the building UA value. Now I know that UA is a little bit geeky, and so I want to quickly show you some examples to help you understand this concept. These calculations were done on a 2,400 square foot two-story home with 15% window area to floor area ratio. So let's start with windows. When we say UA, we literally mean multiplying the U value, or 0.35, by the area of the component, 360 square feet in this case, to get the UA value of 126. Like ERI scores, the lower, the better. So you can see that as we improve the windows, the UA gets lower, okay? So that's the calculation, and you can see the change in UA right there. Now pay attention to how much the UA is changing when we improve the window U value from 0.35 to 0.3 and then down to 0.25. The change in UA is 18, and that's a big change actually, because sadly windows have the equivalent of very low R values. So small improvements make a big difference. Now let's look at walls. We're going to do the exact same calculations here. All I want to point out is the change in UA. So going from R13 to R15 has about the same impact as improving the windows from 0.35 to 0.30. You can also see that going from R13 to R15 has about twice the impact as going from R19 to R21. In other words, diminishing returns as you increase the insulation. And finally, let's take a look at ceilings. Insulation levels are pretty high to begin with in ceilings, so increasing the R value has a pretty modest impact. In short, if you want to improve your UA, you'll get the most bang for your buck from windows, then walls, and then ceilings. So what are the thermal backstops of the ENERGY STAR program? Well, under National 3.1, the thermal backstop is tied to 100% of the UA of the 2009 IECC prescriptive path. For homes certified using 3.2, the thermal backstop is more stringent. It's aligned with the 2021 IECC prescriptive levels. For homes that are permitted before January of 2025 and certified using version 3.2, a thermal backstop of 105% is allowed. So it's a little bit less stringent. And then after that, it drops down to 100% of the 2021 IECC UA. So if you're not familiar with the requirements of the 2021 IECC, I've listed those here along with the 2009 IECC for comparison, and the changes are shown in green. And today we're just focusing on Climate Zone 5, where Massachusetts is located. I'd call these sort of moderate changes. The 0.3 windows are probably what most of our partners are already using or close to using today. The R60 ceiling is a significant jump, but from relatively high levels to begin with. That means a relatively small thermal impact. I'd say the same deal for the walls, and the foundation insulation increases are not nothing, but not unheard of either. So if this looks a little bit imposing to you, don't worry. We'll discuss how the UA trade-offs can be used to make this a little bit more achievable. So let's take a look at a home with a conditioned basement in Climate Zone 5. Again, the 2021 ICC has increased requirements almost across the board. So one option would be to just use these higher levels. That would, by definition, meet the requirement. But let's say that you want some options. So first, let's say that you're certifying this home to version 3.2, but it's permitted before 2025. That means that you can use the less stringent interim thermal backstop. And you think you can do maybe R49 in the attic, but you're not ready to step up to R60. Let's say that you're comfortable with R21 in the walls, but not continuous insulation yet. And you can bump your windows down to 0.29 U factor. And let's say that you're also willing to upgrade your basement walls to R19. Well, this wouldn't hit the 2021 IECC UA. It would actually be about 4% worse, as is shown at the bottom of the column. But because the home is permitted before 2025, that's good enough to certify the home. So that would be a good stepping stone. Now, if the home is certified under version 3.2, but it's permitted after 2025, then you're gonna have to do a little bit better. So say that you're okay with upgrading the attic to R60, but you don't wanna add continuous wall insulation, and so you stick with a high density batt product. If you use the same insulation in the basement walls and make another modest window upgrade, then you're there. You meet the 2021 ICC UA. What if R60 is a step too far for the attic and you want to go back down to R49? Instead, you decide you're going to put a little bit more insulation into the wall assembly and upgrade to R23. You pair that with the same modest window upgrade and you're there as well. And I'll give you one more option. I mentioned earlier how much windows can improve your UA. So what happens if you invest in windows with a U value of 0.25? These aren't as common today, but that level can be achieved with a double pane window using existing technology. We actually expect windows like this to become more common in the next few years. With such a good window, you can stick with R49 attic insulation, you can stick with the R21 batt in the wall, and you can actually downgrade back to R13 in the basement and still hit the target. So you can see just how impactful windows are. I'm really encouraging partners to take a close look at windows, particularly for mixed and cold climates. While windows with a U factor of 0.25 or better may have been rare in the past, we think that the market is going to be developing and evolving quickly here. That's because there was a new product specification for ENERGY STAR residential windows, doors, and skylights that went into effect last October. So this is the spec that allows window manufacturers to put the ENERGY STAR label on the actual product. And I think that's really going to increase the availability of efficient double and triple pane windows. That's because the ENERGY STAR window spec has really high market penetration. The most recent estimate from 2020 was that 84% of windows shipped in the US were ENERGY STAR certified. So here's the new spec. You can see that in the blue region, which covers climate zone 5, it requires a U factor between 0.22 and 0.26, depending on the solar heat gain coefficient. And what I've heard from our Windows expert at EPA is that windows down to, say, 0.24 U factor or so can be made with double pane, not triple pane technology. So it makes it really easy and affordable to drop these into your designs. So I encourage you to ask your window suppliers about this, see if they have new options, particularly in that 0.24 and 0.25 U factor range. Okay. That was a lot of information, so it's time for a pop quiz. First up, what's the key difference between version 3.1 and version 3.2? Option A, you have to meet a more stringent ERI target. Option B, you have to meet a more stringent ERI target and a new thermal backstop. Or option C, battery storage is required in every home. So let you think through that for a minute. All right, we're over 50%. The numbers are rapidly rising. Just about to hit 2/3 if one more person answers. Okay, great. We're at 70%. 96% of you are correct. The answer is B. It's a more stringent ERI target and a new thermal backstop. Those are the only two changes. Let's do another poll question. What's the typical range of ERI targets for version 3.2? Is it A, about 0 to 10? Is it B, that it's 50 for every single house? Or is it C, that it's about 45 to 55 for most homes? All right. People are thinking through this one. People are like geared up to answer now. Their responses are coming in much more quickly. It's great. So we're almost at 2/3. I'll wait for another second. Maybe a person is thinking through all their options here. Okay, we're over 70%. It's pretty good, pretty solid. People are paying attention. Again, 96% of you, must be the same 96%, answered correctly, which is C. It's about 45 to 55 for most homes. And last question for this section, which homes have to meet a thermal backstop equal to 100% of the 2021 IEC-CUA? This is a little bit of a trickier one. So is it A, all homes certified using National 3.2? Is it B, all homes certified using National 3.2 if permitted on or after January of 2025? Or is it all homes certified regardless of the version if permitted on or after January of 2025? And tell the people definitely need to spend a little bit more time thinking about this one. Just over half, so let me give it another minute here. Never hurts to guess. You won't be called out for a wrong answer. Okay, we're just at about 70%. Okay, so 58% of you had the right answer, which is B. 25% of you thought it was all home certified using National 3.2. Just remember that there's a less stringent backstop in place if the home is permitted before January 2025 and it's being certified under 3.2. And 17% of you said C. The more stringent backstop that we've been talking about only applies to homes certified under 3.2, not homes certified under 3.1. All right, great. So that's most of what I wanted to cover today about the core ENERGY STAR program. If you'd like to get started as a builder, here's what you can do. First, I'd recommend downloading a one-page builder and developer fact sheet that reiterates a lot of the information we talked about today. Again, you can click on that link when we send around the slides. Next, you can click on the second link to find a rater and analyze how close your home plans are to achieving ENERGY STAR. So doing like a gap analysis is a great place to start. You may find that you're actually a lot closer to hitting 3.2 than you expected. And number 3, I'd go ahead and sign our free partnership agreement. That just makes you eligible to certify homes as a builder. So So it's great to get it out of the way, take care of it up front. No real commitment. It's just an agreement with us on how to use the logo and that sort of thing. Okay, so that's it for the ENERGY STAR Single Family New Homes program. I want to switch gears and dive into the ENERGY STAR NextGen program. Keegan, are there any questions you wanted to call out now, or should I just keep moving ahead here?
There's a couple, but I think we can save them for the end. So why don't you keep moving forward?
Okay, sounds good. So let's start with a little bit of context here. This is getting geeky up front, so don't worry, the rest of the presentation won't be all this geeky. But according to the Department of State's long-term strategy of the United States, and this has to do with defining pathways to get the whole economy down to net zero greenhouse gas emissions, the vast majority of emissions reductions are going to come from just three strategies: energy efficiency, clean energy, and electrification. So ENERGY STAR, like we were just talking about, has traditionally focused on the first of those, energy efficiency. But now with ENERGY STAR NextGen, we're including elements of electrification, specifically guiding people on how to do this the right way. And the reason that electrification is so important to emissions reductions is that electricity is getting cleaner every year. So this is a chart of the electric power sector emissions over time. You can see that we sort of peaked in emissions in 2005, and the story has been improving ever since then, partially because of the transition from coal to gas, and then also because of renewable energy. So renewable energy generation has just about doubled in the past dozen years. And the US Energy Information Administration's annual energy outlook conservatively predicts that renewable production is going to increase by more than fivefold over the next few decades. The result of current policies at the utility level, the state level, and the federal level is, as you can see here, much cleaner electricity. And I'd like to call out in particular the impacts of the clean energy investments from the recently passed Inflation Reduction Act. So you can look at the 2022 outlook, that's the dotted blue line, the highest line there. And then the Inflation Reduction Act came out, and the 2023 outlook in the solid blue line reflects the impacts of that legislation. So you can see how these policies are expected to reduce the future emissions of electricity production by nearly 50%. So electricity is getting a lot cleaner, so by switching fuels over to electricity in homes, that can reduce emissions. So ENERGY STAR NextGen builds on the successful foundation of ENERGY STAR that we just discussed. NextGen was just introduced last year. It defines the major elements and technologies necessary in new homes and apartments to support significant emissions reductions in a national platform. We believe that the ENERGY STAR program can play a key role in enabling this future, while also ensuring that the program continues to deliver the associated benefits that partners and consumers have come to expect, like comfort, durability, and improved indoor air quality. Now, this is a leading specification. That means that not everyone might be ready for it today. It's meant to be forward-looking, but it's important for builders as well as policymakers to be heading in the same direction. So this is a model that points us towards the future. And our new certification program, just in case you're wondering, is not intended to be a replacement for the core ENERGY STAR program we just discussed, nor the Department of Energy's Zero Energy Ready Homes program. Instead, it's going to work in conjunction with these programs to provide an additional level of recognition for those builders who are ready to step up to pursue it. So this is a very cheesy way of making a point, but we want ENERGY STAR NextGen to be the Wayne Gretzky of above code new construction programs, sort of leading the way of where we think new construction needs to go. So with that brief intro, let's get into the actual requirements. Here is a quick overview. Once again, we can put all the requirements of NextGen and summary on a single page. Our program starts with highly efficient construction as defined by our core ENERGY STAR program. And then it adds a set of specific, achievable, and market-ready prescriptive requirements. They cover connected space conditioning heat pumps, connected heat pump water heaters, electric cooking, and EV charging capabilities in all homes and apartments that earn the new certification. Each measure required in NextGen can be independently verified by the same raters that are completing the verification for the ENERGY STAR core program. And these new requirements can be documented by a rater using a single one-page checklist. Now, one important note I'd like to call out is that we're not requiring all electric homes and apartments or banning gas. we framed our requirements around what is present in the homes and apartments, not what is prohibited. Another consideration is that program sponsors can always add requirements to our program that meet their needs while still retaining the label and the certificate. So they can't remove things from NextGen, but they can layer on additional requirements, as Keegan was alluding to with the incentives he talked about at the beginning of the presentation. So that lens helped us focus our certification on what we believe to be the most important features for reducing emissions in residential new construction. So let's just go through these in a little bit more detail. The first one's super simple. The first requirement is to earn ENERGY STAR NextGen is to meet the most advanced version of the core ENERGY STAR program, as we just discussed, for single-family new homes in Massachusetts. That would be national version 3.2. So you start with high efficiency. That really enables all the other features in NextGen. That brings me to heat pumps. So there are 4 related requirements to space heating heat pumps. And the first is that homes and dwellings have to be equipped with a properly sized 2-speed or variable speed ENERGY STAR certified heat pump. You might already know that heat pumps provide more comfortable air than furnaces because they heat at a cooler level, like a lower level. Hotter furnace air can over dry the air in the winter, and that can lead to dry and itchy skin. So that's one comfort value of heat pumps. In addition to installing an ENERGY STAR heat pump, we've included a few requirements to better ensure a positive occupant experience. So multi-stage or variable speed technology is a requirement because it offers the consumer amenities of being quieter while delivering more consistent temperatures for greater comfort. We can safely say that properly sized multi-speed systems that have sufficient return air are going to be quieter than their single-speed counterparts. So for anyone like me who has a return grill right next to me in the living room, for example, this is a really important feature to promote, just the quietness of these systems. For projects in climate zones 5 through 8, like Massachusetts, the installed heat pumps must also meet the ENERGY STAR cold climate criteria. These requirements are designed to ensure that heat pumps perform well and that they remain efficient even at low outdoor temperatures. Now, if you don't have a lot of experience with cold climate heat pumps, that's okay. That's one reason we have them in the program, to grow experience, but they've been getting successfully installed in some of the coldest climates in the US over the past decade or more in both new and existing homes. So for example, Efficiency Maine shared some testimonials from owners of recently installed heat pump retrofits after a really brutal winter cold snap. And the homeowners were really pleased with the results, both lower utility costs and the comfort provided by these systems, even on the coldest of days. Now, at the end of the day, for NextGen, you don't have to trust us. We would allow you to put in a gas backup system, but I know that Keegan highlighted for the incentives that are available, you have to stick with an all-electric backup system. Each installed heating and cooling system also has to meet EPA's connected criteria or be controlled by a Wi-Fi enabled thermostat, such as an ENERGY STAR smart thermostat. ENERGY STAR smart thermostats are generally recommended for all 2-speed systems. For variable speed models, you just need to ensure that the thermostat is really designed to work with it for proper operation. So that's where you might end up defaulting to a non-certified Wi-Fi enabled thermostat instead. Our final requirement for heat pumps is HVAC rating. So let me provide a really quick overview for those who haven't heard me talk about it. There are 5 key tasks in the HVAC rating standard. They include a design review, a total duct leakage test. Both of those should be very familiar to current ENERGY STAR partners. And the new additions are a measurement of blower fan airflow, blower fan watt draw, and finally an assessment of refrigerant charge. Doing these 5 tasks gives you a wealth of information about the heating and cooling system that can help save energy and reduce your risk as a builder. But on top of that, HVAC rating makes it easier to certify ENERGY STAR homes and apartments in a few different ways. It integrates most of our HVAC requirements directly into an energy rating. So there's less stuff you have to do specifically for ENERGY STAR. It doesn't require the use of a credentialed HVAC contractor, which has been a sticking point in some markets. It also eliminates the completion of the HVAC commissioning checklist, and it rewards proper installation with ERI points, which can help you meet that ENERGY STAR ERI target. It helps you meet 45L and these incentives. So we think these systems offer real benefits to consumer. Our primary talking point is that on this feature is that ENERGY STAR NextGen homes and apartments allow you to take control of your comfort with a quiet and responsive heating and cooling system. And consumers are really getting wise to the benefits of heat pumps. The number of heat pumps sold outmatched the number of gas furnaces sold for the last 2 years, and that delta is only growing. Our next requirement is for efficient water heating. ENERGY STAR certified heat pump water heaters are up to 4 times more efficient. They use 70% less energy than a standard model. They save hundreds of dollars every year in energy costs. And on top of that, we also require that they meet ENERGY STAR's EPA connected criteria. That's because water heating is an ideal demand response opportunity. Connected electric water heaters can shift up to 1 kW of demand per response event through preheating. So you still have the hot water, it's just being heated at a different time. And that requires that communication ability to load shift and respond to demand response events. So our little team has installed at least 3 heat pump water heaters in our own homes. They're working great. They provide sufficient hot water. They operate quietly. And while they do produce a little bit of cool air around them, it's not to a degree that it's a problem for the locations where they're being installed. On top of this key requirement, we have a few other related to water heaters to ensure good performance. This includes installing a quiet model with a sound rating less than 55 decibels. Since heat pump water heaters can make more noise when operating than some gas water heaters, we've included a sound rating limit that ensures that they're installed within a dwelling unit's occupiable space. This requirement will make you install quieter models so that it precludes louder units from being installed in locations where occupants would frequently hear them. And finally, we require the heat pump water heater to be properly sized. So the minimum tank size ensures that a majority of the water heating is done by the heat pump rather than its electric resistance backup coil. It's based on the number of bedrooms in the dwelling, as you can see here. And of all the requirements in ENERGY STAR NextGen, heat pump water heaters will require the most advanced planning because integrating heat pump water heaters into your space requires a sufficient volume of air for them to work properly. So if they aren't already part of your planning, you need to start thinking about where heat pump water heaters might be installed as you are developing your future plans. And we've just finished a technical guide on heat pump water heater installations for residential new construction. So if that's a new technology for you, I'd encourage you to download the brochure at the link shown here. I know we're bumping up against the hour, so I just have maybe about 5 more slides, give or take, and then we can open up for questions. So hopefully you can stick around for that. ENERGY STAR NextGen is intended to be forward-looking, and the adoption of electric cooking appliances is a key enabling technology for lowering emissions in residential new construction. Optional induction cooktops, and not just electric, but induction, they deliver consumer amenities that should be highly desirable, but a lot of buyers in the US are unfamiliar with this technology today. They can boil water in half the time of gas, they're cool to the touch, and that reduces burn risk. The cool surface also makes them easier to clean. It allows you to clean the surfaces more easily and use the space as counter space when it's not on. They also offer more precise temperature control, making cooking easier. And in fact, our team has installed 2 induction cooktops in their own home so far, and they're really loving it. So this is why major appliance manufacturers are making induction a strategic centerpiece of their lineups. And it's not surprising that sales of induction ranges have increased 40% in 2022 over 2021 levels. And also, as they become more popular, the prices have started to come down. So if you include induction cooktops, you can promote this new technology and its better cooking experience to consumers. It's also good to be aware that the ENERGY STAR team released a new spec for residential electric cooking products earlier this year. That includes both electric and induction cooktops. Kitchen appliance manufacturers have started certifying these products to the new specification, and we're closely tracking the development of those products because that might be something that we require in future versions of NextGen. And finally, let's talk about EVs. So electric vehicles have the potential to affect nearly 1/3 of the nation's total energy use and lower the nation's transportation costs and substantially lower emissions in transportation. 3 in 10 Americans say that they're somewhat or very likely to consider an electric vehicle for their next purchase. An understandable reason why this number isn't even higher is that a lot of people are concerned about how to charge their systems. So for electric vehicles really to take off, there needs to be charging options both along interstates and at home. In fact, 90% of EV drivers report that they want access to home charging, which helps explain why more home buyers and renters are increasingly valuing EV charging at their homes. So making buildings ready for EV charging can reduce further installation costs by a lot, 75%. and should make buildings that include EV charging capability more desirable to many prospective customers. That's why our fifth and final feature is that NextGen certified homes and multifamily developments with private parking have to include EV charging capabilities. For single family homes and 2-unit dwellings that provide private parking, they have to be EV ready, by which we mean a powered 208 or 240 volt receptacle in the garage or within 3 feet of the driveway or dedicated parking space. And the electric service panel has to include a 40 amp or greater breaker tagged as being for electric vehicle charging. And in multifamily buildings, as well as single family units without private parking, they have to provide one EV ready space for each dwelling unit, like we just discussed, or install ENERGY STAR certified EV chargers for at least 10% of the parking spaces, up to 5 total, and have an additional 20% of spaces be EV capable to enable the future installation of EV chargers. Projects that don't include private parking, don't have to install EV charging infrastructure. This just gets into promotion of EV charging. I'll just breeze through that. So let me just wrap up by talking about how to get started with NextGen. I'll kind of breeze over this as well. It's an important point. There's a lot of overlap between version 2 of the Zero Energy Ready Homes program at DOE and these NextGen requirements. So if you're already thinking about doing NextGen, then you might also consider stepping all the way up to Zero Energy Ready Homes, which would unlock an additional $2,500 tax credit. So that's what I want to call out here. Keep that in mind if you're exploring NextGen. Okay, so if you're a rater, what are your next steps? First, you need to take the ANSI 310 HVAC rating training from your home certification organization, so you can use that to help certify NextGen homes. Second, we encourage you to get more familiar with NextGen requirements. All those requirements are in the rater field checklist, which is just a page that's shown on the left here. And we're going to have more specific rater training coming out soon, so you can keep an eye out for that. And finally, builders are going to expect you to become an expert on NextGen technology. So you need to keep up on these new technologies that are emerging. I mentioned a technical heat pump water heater guide that we just developed. There's also some great trainings on cold climate heat pumps from reputable organizations like NYSERDA and the Northeast Energy Efficiency Partnerships to help you get started. And we'll be developing more resources as well. Okay, so that was a little bit breakneck, but hopefully you internalize some of that information on NextGen. Let me pause here and see if we have any questions.
Yeah, thanks, Dean. Yeah, there's a couple questions, and I know we're a few minutes over, but it looks like folks are hanging on, and I know you can as well. So the first question is a manufactured home a trailer home or a modular factory built? I think this one came in pretty early on in the slides.
Yeah, so manufactured homes have a very specific definition. They're constructed in a factory on a chassis, and they're meeting, by definition, a HUD energy efficiency code. And so we have a whole separate set of program requirements for HUD manufactured housing. So the trailer home, the manufactured home, mobile home, those are all kind of terms that are used to describe these sorts of homes. So if you are building those sorts of homes, you should look into our manufactured homes program requirements. That also would enable you to be eligible for a tax credit. It's just a different set of program requirements. If instead you're building modular homes, which is not built on a chassis, not under the HUD code, they typically fall under the site built code, but they're like modules that will get shipped to a site and assembled on site. That would just fall under our single family new homes program requirements. So the trick there is you need to have a rater in the factory to verify the things that they won't be able to see in the field. So it takes a little bit more coordination. It's something we're exploring more about, maybe improving the process in the future. That's a short answer, and if you have additional questions about that, we can follow up after the webinar.
Great. Hybrid tank sizing is based on bedrooms to kick over heat pump efficiency and not number of baths.
Yeah, number of bedrooms is typically what drives, as I understand it, the like plumbing code sizing, because it's a driver of how many people are in the home, not necessarily how many bathrooms are in the home. And so it's tied to that, and the point is to have enough capacity so that the heat pump water heater doesn't have to constantly kick into its electric backup mode to create hot water quickly when there are high use events. We want as much of that operation to be in the compressor mode as possible to maintain its rated efficiency.
Great. Do you have data on how many projects, Energy Star projects, specifically in the Northeast, have used the Rater HVAC grading path? And can you speak at all to the time needed or potential risks with that in ducted versus ductless systems?
Yeah, it's the standard came out in 2020. We have more raters and providers ramping up its use now. We have tens of thousands. I don't know about the Northeast specifically. We have tens of thousands of homes that are using the HVAC rating standard now, and I expect that to only increase in the future. It's actually been fairly popular in the sense that one of the sticking points in the past with our old HVAC requirements in some markets has been the lack of credentialed HVAC contractors, which is what's required under the other track for satisfying our HVAC requirements. So with HVAC grading, the nice thing is that all of the verification is done by the rater, so we no longer have to rely on a credentialed HVAC contractor to do the verification. In terms of the timing, it's like roughly, it depends on the system, the approach you're using, and everything else, but maybe roughly like 40 minutes per system, give or take, to do all those tasks. There's a design review you can get out of the way before you get on site. You're already doing total duct leakage on every house today for Energy Star, so that's not an added amount. So these extra tasks of measuring airflow, measuring watt draw, and assessing refrigerant charge is maybe 40, 45 minutes per system. If you are investing in a ductless system, like a ductless mini split, you actually automatically achieve grade 1 for some of these tasks. For duct leakage, obviously, because there are no ducts, for airflow, and for watt draw. So if you're using a ductless mini split, really the only new assessment you're doing in the field is the refrigerant charge assessment. And so that's one strategy to kind of fast track, is you get a lot of free passes if you're using a ductless mini split system. I think that answered most of the questions. If there are more on that, let me know.
Yeah, thanks, Dean. Another one, if a home does not have R5 continuous exterior insulation, but still meets the UA requirements, is it able to still claim the tax credit?
Yeah, great question. The answer is yes. And so we've intentionally included that UA trade-off because we knew, for example, that the continuous insulation requirement was a sticking point for a lot of builders. And so, you may end up investing in really good windows instead, still have an equally good overall thermal enclosure without the continuous insulation, and the home can still be certified and it can still receive the tax credit. So that is a great strategy to consider if you're not ready to step up to continuous insulation, even though continuous insulation does offer a lot of benefits. So I don't want to like poo-poo the idea, but it might be a step too far for some builders, and they have a lot of room for improvement left in the windows. They might just choose to go that route instead for now. So great question.
Is ResNet still providing no-cost ResNet 310 training for HVAC rating?
Yeah, so if ResNet is your home certification organization, they have 4 modules that are through their online learning platform that are free. That's the kind of mandatory training that a rater has to go through before they can start using 310, along with, I forget the technical term, but it's basically like someone watching you do an installation in the field to make sure you're doing it correctly, like a proctored sort of practical exam. So that's like the bare minimum. Separate from that, we have heard of some providers out there that are doing hands-on on-site training. So that's something that you would pay for above and beyond the mandatory training. But some raters really value, being in a classroom and then in the field with a professional to run through all the tasks again. So I encourage you to also look for additional training if you're still not, satisfied with the free training you start off with from ResNet or your own HCO. And if you want some connections on that training, you can reach out to me afterwards, and I can share those with you.
Yeah, Dean, if you want to just flip back maybe a slide, I think you had your contact on that. Yeah.
Yeah. Yep.
Great. Well, I think that's it for questions. So if there are any ones that weren't answered, or you think of something later, don't hesitate to reach out to Dean there, or you can reach out to the Mass Save program. Dean, again, thanks so much for your time. Thanks for joining us, and thanks to the sponsors of Mass Save for hosting this this session today. The recording will be made available online shortly.
Great. Sounds good. Thanks, everyone. Appreciate you taking the time out of your day to sit in on this.
Thanks, Dean. We'll talk soon.
Okay. Bye, everyone.